Okay, today we have the corrections for class test on differentiation 2, the one with the connected rates of change. Okay, first determine the range of values of x for which the function is a decreasing function. Okay, first what I have done here is this. I have expressed it in this form u times v. So what I can do is I can differentiate, alright, to get using the product rule. So u is x, du dx is 1, v and dv dx. I apply product rule, v du dx time plus u dv dx is this. Okay, what I get down here is this function. Okay, for this question I shall combine them. Alright, so what I do is I have expressed this. Okay, I times x squared plus 3, x squared plus 3, I get this term. I combine them, I get 3 minus x squared over x squared plus 3 squared. Okay, now we know that for a decreasing function dy dx is lesser than 0. So this one is lesser than 0. Now we know that if I want this fraction to be lesser than 0, notice that the denominator, okay, x squared plus 3, any number, any real number of x, you put it in, you square it, you're going to get a positive number. Okay, so because you put in number here, you square, okay, positive number, you add, you square again, it's going to be a positive number. Therefore, what we need to do for this dy dx to be lesser than 0 is for the numerator, this negative divided by positive will be a negative number. Hence what I'm looking for is for 3 minus x squared to be lesser than 0. So we have to solve this inequality. So I write 3 minus x squared is less than 0. Multiplying throughout by negative 1, I get x squared minus 3 is less than 0. Here's where I apply a squared minus b squared. 3 can be written as root 3 squared, a plus b, a minus b. So I've drawn this here. It's a x squared smiley graph. The roots are root 3, negative root 3 I put here. The region I'm looking for is the one less than 0. That's why I have shaded this portion here, less than 0. So therefore the range of values of x for which the curve, okay, is less than 0 will be from negative root 3 to root 3. Hence, okay, between negative root 3 to root 3, my function will be a decreasing function. I move on to question 2. Okay, for question 2, first we have a line, y equals 9x plus 12. I can say that the gradient is 9. Okay, we have a curve here. I differentiated 3x squared, 2ax plus 12. Okay, the question actually tells us that the tangent to a line at x equals to 1 is parallel. So that means at x equals to 1, okay, the tangent, okay, has a gradient of 9. Because if it's parallel to this line, means that the gradient is 9. So after that, at x equals to 1, I sub it into here, 3 times 1 squared plus 2a times 1 plus 12 equals to 9. The rest of it is simple solving to get me a is equals to negative 3. I move on to question 3. Question 3 part 1 tells us that the volume is 324 pi. So volume is also given by 4 pi h cubed over 9. I equate it to 324 pi. Okay, I multiply both sides by 9, I get 2916 pi. I divide both sides by 4 pi. Pi divided by pi will eliminate. 2916 divided by 4 is 729. You cube root both sides, you get h is equals to 9 cm. Simple enough, 2 marks for 3 part 1. Now I move on to 3 part 2. Okay, 3 part 2 is the connected rates of change. Notice that on the left hand side we have v. Okay, so it's v, yeah? So v is 4 pi h cubed over 9. So we always start, since v is the subject, we write dv dt is equals to dv dh times dh dt. Okay, first I show you how to differentiate v first. If you write it out, okay, 4, pi and 9 are all constants, so I put it in the bracket here. So the one that we're actually differentiating is h cubed. So when you differentiate v with respect to h, you bring down the 3, okay, 4 pi over 9, h, reduce the power by 1, 3 minus 1 is 2. So I get 3 and 9 will eliminate to give you 3. So it's 4 pi over 3 h squared. I just plug it in over here. dv dh is 4 pi over 3 h squared times dh dt. Okay, how I get this thing here, dh dt is from here 3 times negative 16, okay, gives you negative 48. I divide by 4 pi h square. I put it below. Then we know from the previous part 1, that h is equals to 9. Just plonk in h equals to 9, press calculator, you get negative 0.0472 cm per second. And that's it for the corrections for differentiation 2. Thank you for watching.